Hello everyone. Today we are going to start a new chapter which is periodic classification of element. Myself Suman Singh. So when we talk about the periodic classification of elements, till now we have total 118 elements, okay? And these elements form a large number of compound, okay? So, the systematic study of this element and their compound is possible only when these elements are arranged in a simple way, or we can say that when these elements are arranged in such a fashion that the arrangement is closely related to their properties and make a study make our study simpler. Okay, so why there when we talk about why there is a need of classification of the classification and of the periodic table, and then why there is a need of classification and the periodic table. So as we know, till 17th century a very few number of elements were known, okay, but in 18th and 19th century several new elements were discovered, okay. So with the discovery of more and more element, chemists began to realize that these elements should be arranged in a proper way, okay. These elements should be arranged in proper way to facilitate their systematic study, okay. So, to study this element systematically, to study these elements we have to make a systematic arrangement, okay. Why there is a systematic arrangement is necessary? Because this element and have loads of compound, or we can say that these elements and their compound show a great variation in their chemical behavior, okay. These elements and their compounds which is formed by these elements show a great variation in the chemical behavior, and it was not possible to study them in a haphazard way, okay. So several efforts were made to classify the known element in a systematic way. So in classification, the first meaningful effort in this discovery was made by Russian chemist Dmitry Mendeleev. Okay, you can see the name here, Mendeleev. Okay, so Mendeleev, what did he does did what was his work? He deeply studied the physical and the chemical properties of the element. Okay, and then he classified them on the basis of the periodic law. Okay, means what? He has first of all, one by one, he has studied the physical and the chemical properties of this element, and after studying that chemical and physical properties, he classified them, these elements, on the basis of periodic law, okay. So now after this information, whatever we I have told you, from this information how can we define periodic table? So we can give a very simple definition. A periodic table is an arrangement of all the known elements based on a certain law known as periodic law in such a manner that the elements with similar property fall in the same vertical column and group. Okay, so this is a simple definition which we can give to describe periodic table. Now after that we will see the earlier attempt to classify the element. Earlier attempt to classify the element. So in the earlier attempt to classify the element, Number one, which we will learn, is Dobbeneer triads. So, what is this Dobbeneer triads? Dobbeneer was a German scientist, or we can say chemist. He found that the element could be arranged in a group of three called triad. What does he have told? He found that elements could be arranged in a group of three called triad. Okay, in such a way that the middle element had an atomic weight almost the average of the other two. Okay, so I will explain you this one, what he was telling. Suppose we have here lithium. You can see here, I will explain you from this diagram, from here. Okay, so you see lithium has an atomic number 7, atomic mass 7. Potassium has 39. So when we will add this 39 plus 7, it will become 46, right? 9, 15, yes, 46. 46 divided by 2. So when we will divide, we will get 23. So 23 will be the atomic mass of this sodium. In this way, he arranged the element. One more example you can see here. That is calcium, strontium, and barium. So calcium is atomic number 40. Strontium calcium has an atomic mass 40. Barium has 137. So when you will add this two and when you will divide by 2, you will get 88, approximately 88 point something. Okay, now next you can see here one more example. Chlorine 35.5, iodine 127. So when you will add this two, you will get almost 80 point something. So this was his classification. Okay, so in this way Dobbeners try to uh, in this way the Dobbener tried to classify the element, okay, into the group of 3, but his idea has failed because most of the elements we can't place like this. Okay, so his idea has failed very soon. After that, one another scientist called Newland, so he was an English chemist actually. So what did he say it, or what did he found, that if the element are arranged in the increasing order of their atomic weight, okay, the properties of the every eighth element were similar to those of the first one. Okay, if you will see here, I will tell you how you can see. You see here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, so this is, and after fluorine it is coming sodium. You see here, after that magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. So when you will see lithium and sodium has a similar property, beryllium and magnesium has a similar property, boron and aluminum, carbon and silicon, nitrogen and phosphorus, oxygen and sulfur, fluorine and chlorine. Both, all of them has a similar property. If you will come downward, you will see lithium, sodium and potassium. Both, three of them has a similar chemical property. Here also calcium, magnesium and beryllium, both of the three of them has a similar chemical property. So in this way, Newland has tried to arrange the element, but his idea also failed because with the discovery of more and more element, the arrangement was, it was not possible to arrange the elements like this. So his idea is almost failed. Okay, after that Newland, Mendeleev classification used to has came forward. So what was Mendeleev's idea of classification? We can say like this: the first meaningful and remarkable contribution in the field of classification of element was made by this Mendeleev. Okay, what did Mendeleev did? Mendeleev used a broader range of physical, or we can say that Mendeleev used a wider range of physical and chemical properties of the element. Okay, and element as compared to those used by Lothar-Meyer. Okay, wait, let me give you some idea about the Lothar-Meyer. Okay, after that we will see Mendeleev. Here it is not mentioned, but just for a sake, because in your syllabus when you will see, it has started from Mendeleev, but I am giving you just because you should know the past. That's why means what was the previous uh, classification of element. That is why I'm just giving for your kind information. Okay, but in your syllabus it is started from Mendeleev. So there was a scientist called Lothar Meyer. He was a German chemist. Okay, what did he done? He has plotted various physical properties of the element, just like atomic volume, density, melting point, boiling point, thermal conductivity, etc. He placed this physical property against the atomic weight. Okay, he placed, suppose it was graph was like this. Here atomic weight, suppose here atomic number, and here atomic weight. Okay, so he placed he has plotted the various physical properties of the element against atomic weight, and he found that the properties varies in a in the periodic function. We can say like this. The when he found that these properties varies in a periodic function. Okay, so on the basis of his study, he arranged the element in a way that resemble nearly the Mendeleev arrangement of element. Okay, but however, Lothar Meyer is more remembered for his atomic volume curve than for his arrangement of element. So Mendeleev, basically what he did, he used a broad range of physical and chemical properties of the element as compared to those with the Lothar-Meyer. Okay, and studied the formula and properties of the several compounds of the element of an element. Okay, and on the basis of these studies he has developed a law which is called Mendeleev periodic law. Okay, and what was the basis of this periodic law? The basis is that the physical and the chemical properties of the element are the periodic function of their atomic masses. Okay, the physical and the chemical properties of element are the periodic function of their atomic masses. Okay, now what was the contribution? When we talk about the contribution of this Mendeleev in the arrangement, or we can say that the main features, or we can say that main features, yes, we can say the classification, or we can say contribution word will be suitable. Contribution for of Mendeleev periodic table. So his contribution was to systematically study the element. Mendeleev periodic table categorized the element for the first time in a systematic way, and this helped immensely in the study of the chemistry of element and their compound, and made the study much easier. Okay, and number two, what he did, his contribution was the discovery of new element. Means what? Mendeleev has left some gap in his periodic table. When you will see the Mendeleev periodic table, you will notice that he has left some gap. When you will see this one carefully, you will notice that he has left some gap. Okay, he left some gap in this table, and he what did he did Mendeleev just predicted the physical and the chemical properties of some element which were not known at that time. Okay, and left the gap for them in his periodic table. Okay, what he did, he just predicted the physical and chemical properties of some element which were not discovered at that time. Just he predicted the physical and the chemical properties of that element, known element, and he left some gap in his periodic table. Later on, which was discovered by some other scientist. So we will see that what was that element. That element was, yes, you can see here, it, yes, it is given here. This element were, he has given the name Eka aluminum. Okay, he has given the name Eka aluminum, so which was later on discovered by Bias Bendrom in 1875, and he has given the name gallium. And the property which he has predicted was almost similar, means you can say 99% it was similar to that predicted by the Mendeleev and Winkler. The name here the Eka silicon, you will see Eka aluminum and Eka silicon, right? So Eka silicon was discovered by this Winkler in 1886. This Eka silicon was later name given as germanium, and this germanium property, which was predicted by Mendeleev, is almost 95 or 99.9% correct as predicted by Mendeleev. So this was some of the contribution of Mendeleev periodic table, periodic table. Now next, what was the demerits? So demerits was also there for Mendeleev periodic table. So what was the main demerits is the position of hydrogen. Okay, before that, one more thing. In Mendeleev contribution, he has given the correction to atomic masses also. Okay, some of the atomic masses which were falsely calculated at that time, Mendeleev has corrected that atomic masses, just like beryllium, example of beryllium. Okay, so after that you see demerits. So before demerits, we the demerits of Mendeleev periodic table, when we see this, so main demerits was position of hydrogen. So when we talk about the position of hydrogen, you will see that till now the position of hydrogen is not fixed. It is till now it is a debatable. Some says it should be in group 1, some says it should be in group 17. Okay, so you will see that in long form of periodic table also, some of them are in some periodic table you will see that the hydrogen is placed before above the lithium, or some of them in some periodic table you will say it is written in a middle. So it is debatable. So this was also the demerits of Mendeleev. Mendeleev has also not explained the correct position of the hydrogen. Now next is position of isotopes. Mendeleev has failed to differentiate, or we can say that here the concept, Mendeleev has failed to tell the concept of this isotopes. Okay, now position of lanternoids and actinoids, also he has not given the position of lanternoids and actinoids, and he has not explained clearly about the variable valencies of the element. Okay, and after that anomalous pair of the element. Okay, then the similar element placed in a different group means what? The two elements, the elements like silver and thallium, okay, and barium and lead, copper and mercury, so a similar property, yet they are placed in the different group in a Mendeleev periodic table. Okay, so this is some of the uh, demerits of Mendeleev periodic table. Now after that, this was all about the Mendeleev periodic table. We will see modern periodic table. So when we talk about the modern periodic table, so in modern periodic table, the Mendeleev classification of element in the form of periodic table was based on the fact that physical and chemical properties of the element are the periodic function of their atomic mass, right? But in 1913, yes, in 1913, one scientist called Henry Moseley, okay, Henry Moseley found that atomic number and not the atomic mass. Moseley found that atomic number and not the atomic mass is the most fundamental properties of an element and is responsible for its physical and chemical behavior. So this discovery of Moseley has entirely changed the Mendeleev periodic table concept, because it was based on mass, but now Moseley is telling that it is a atomic number is the most fundamental properties of of physical and chemical property, chemical behavior. Since the Mendeleev periodic table contains several animal means limitations, okay, it was though to change the basis of the classification from atomic mass to atomic number, and this gave a birth to a new periodic law which is called modern periodic law. Okay, so I hope you have understood this. So in modern periodic law, what does this modern periodic law says? Modern periodic law is based on atomic number. I hope you know this, you have also learned this in class junior classes. So what does this modern periodic table so tell? Modern periodic table tells us that the physical and the chemical properties of the element are the periodic function of their atomic number, not the atomic mass. Okay, not atomic number, not the atomic mass. Okay, now, so when we talk about the modern periodic table, modern periodic table has, you can see, 7 period. Okay, as you can see, it has 7 period: 1, 2, 3, 4, 5, 6 and 7. It has 7 period. Okay, and 18 group: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, sorry, 12 and 13 group. Here it has given in an elaborated way, so it will be 18. Okay, means modern periodic table has 7 period and 18 group. Okay, and the basis of its classification is what? Atomic number, not the atomic mass. Okay, so in this long form of periodic table, the elements are arranged in order of their increasing atomic number. Okay, and when the elements are arranged in this modern periodic level in increasing order of their atomic number, the atomic number in accordance to the periodic law, they get arranged in such a way that the elements having a similar physical and the chemical properties appear in a vertical column. Okay, and these vertical column are called group or family, anything. Okay, and long form of periodic table consists of horizontal rows, which I have already told you, which is called period. Okay, total number of period is 7 period. Okay, so when we talk about the period, the first period is called, in the first period there will be two elements. Okay, let me tell you like this. First period, number of elements is 2. Okay, and this is called very short period. Second period, it is number of element is 8. It is called first short period. Third period, number of element is again 8. Okay, and it is called second short period. In the fourth period, again number of element is 18. Okay, this is called first long period. After that, in fifth period, again 18 element. Okay, second long period. And in sixth period it is 32 element. Okay, this is called very long period. And seventh period it is called 32 element. But basically, if you will see, I know you are not referring to NCRT, but in NCRT book, when you will see that this seventh period they have left incomplete according to NCRT, but it is not like this. This seventh period is also completed. Okay, in a new book, which is your school book, which you are going to use. In that book, it is 32 elements is given. Okay, so now, so I hope you have got some idea. So in periodic table, when we talk about the periodic table, this periodic table has been divided into three parts. We can tell like this. First part is a representative element. After that, second part is transition element, and the third is inner transition element. Okay, so this representative element, which one is called representative element? So representative element will be S and P block. Okay, all S and P block element, which is group 1 to 2 and 3 to 18, are called representative element. Okay, now transition element is all D block element are called transition element, which is from group 3 to 12. Okay, and inner transition element, when we talk about the inner transition element is called F block element, which is lanthanoid from 4F and actinoids from 5F. Okay, so now when we talk about the group, so the first group, this one, the first group is called what? This first group is called alkali metal. Okay, I hope you know that. Second group is called alkaline earth metal. Okay, group 15, which is called nitrogen family, it is called pictogen. Okay, group 16, oxygen family, chalcogen. Okay, group 17, halogen. Okay, and group 18 is noble gases, you all know, right? And group 3 is called N plus Lanternoids, is called rare earth metal. So that is the different thing. So now I hope you have got some idea. Now next, lanthanoids or rare earth metal. Okay, when we talk about the lanthanoids, or here if it is given, let me see. Yes, here it is given. So lanthanoids, when we talk about the lanthanoids, the element from 58 to 71. Okay, the element from, now this lanthanoids is the element from 58 to 71 is lanthanoids. After that 90 to 103 is actinoids. Okay, after that these coinage metals are copper, gold and aluminum, copper and gold, these are called a coinage metal. And noble metal, just like gold, silver, platinum, mercury, like this. Okay, so this was all about your some of the basic idea about long form of periodic table. Now again, when we see the filling of electron, I have also explained you in the atomic structure chapter, atomic structure. In atomic structure I have told you, first of all 1s is filled. Okay, after that 2s, then 2p, right? And after that 3s and 3p. Okay, and after that not 3d, right here, not 3d. After that 4s and 4 4s, 3d, and then 4p, right? 4p, right? So when we talk about the electronic configuration, we will see here. Okay, let me go there. Okay, wait, you can start, you can do like this. This one, there is one concept called periodicity. Okay, I hope it is given here. Yes, periodicity. So periodicity means what? Periodicity means the repetition of the periods of element after a regular interval when the elements are arranged in order of their increasing atomic number is called periodicity. Okay, so this, when we learn, when we talk about this periodicity, first of all we will see what periodicity is. Just a regular interval when the elements are arranged in increasing atomic number. Just it is a repetition of the properties of element. You will understand this afterward. Let me explain. Suppose we are talking about the S block elements. Okay, S block element. So when we're talking about the S block element, what are the elements which used to come in S block? Lithium, sodium, potassium, rubidium, cesium and francium, beryllium, magnesium, calcium, strontium, barium and deuterium, right? So these are the elements which come in the S block element. So why it is called S block element? Because if the last electrons enter the S orbits, okay, their general electronic if the last electron enter into the S orbit, then that is why it is called S block element, and its electronic configuration will be what? N S 1 to 2. Okay, which are the elements which come under S block? The alkali metal and alkaline earth metal. Alkali metal, when we talk about the alkali metal, its electronic configuration will be 1 NS1, and when we talk about the alkaline earth metal, it will be NS2, right? Now P block. So when we talk about the P block elements, so P block is P block. Why it is called P block? Because the last electron enters into the P orbit, okay, and its general electronic configuration will be what? NS2 and P1 to 6. Okay, this will be the general electronic configuration. After that, when we talk about the metallic nature increases down the group. When we go down the group, its metallic nature will increase. Okay, after that, D block element. So why it is called D block? Because the last electron enter into the D orbit. Okay, D block. So for D block, the electronic configuration will be what? N minus 1 D 1 to 10 and S 0 to 2. So you can see here why it is writing N minus 1. The reason is, you have seen, right, in the previous also I have explained, after 1s we filled what? 2s. After 2s we filled 2p. After 2p we filled 3s, then 3p, not 3d, right? Before 3d we filled first 4f, okay, after that 3d, then it is 4p. So for in when you will go when you will see the group 4, 1 2 3 4, when you will see the group 4 elements, when you will see the fourth period, okay, 1 2 3 4, so fourth period will start from 4s, right? So after 4s, what is it there? 3d, right? So this is principal quantum number is 4, here it is 3, means the principal quantum number, this one is minus 1, right? So you can see here 4 minus 1 is what? 3. That is why it is written n minus 1. Okay, that is why here it is written n minus 1, n minus 1 1d 1 to 10. Okay, after that ns 0 to 2. Okay, I hope you have understood this. After that, when we talk about the F block, the same thing, last electron enter into the F orbit, that is why it is called F block element, right? So this was some of the basic idea about the periodic table. So in the next class we will start with the periodic properties, just like nuclear charge, valency I think you have learned in junior class also. We will see that atomic radius, nuclear charge, screening effect, all this thing, atomic radius, covalent radius, metallic radius, ladder rule, all this thing we will see in the next class. Okay, till that, keep up to this. Thank you.